Hello everybody, welcome back to From Rhythm to Algorithm Part 10, Dimensionless Analysis. In this episode we are going to literally introduce a new mathematical subject. We're going to pull it together. We've introduced several new ideas both in this lecture series and in my language lecture series, so we're going to start pulling all of those ideas together. Simply dimensionless analysis is the opposite of dimensional analysis. Dimensional analysis is what everyone does in chemistry or physics class or any math class at all with units, right? How many days are in a year? 365 days. So you have, this is just a quick example, 365 days per year. And that is where division comes from. Dimensionless analysis, again, this is the first lecture, so there's going to be a lot more development. We're going to introduce the logical ideas, and we're going to show the consistency, and then we'll work up, and like I said, we'll show, I've been able to solve tension path physics problems since literally high school, so I'll solve like the inclined plane, blah, 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 but I wanted to cover the logical ideas of the mathematics. So dimensionless analysis does not use units. And in the last lecture we discussed, or I keep trying to pin down exactly why we do not need irrational numbers. For the physical reason we do not need irrational numbers. I'm already sure of that mathematically, again, 4 years ago. But the fundamental stability of 2. Right, that's why you say dada or mama, that's why you go 2, 4, 8, 16, 32, blah, blah, blah. In physics, that's why any object, anything, thing being the most general word for any object, it's either mass or it's energy. And so I've been talking a lot about these dichotomistic pairs. Dichotomistic pairs are logical coordinates, right? You have an xy plane, it tells you where you're at on the x-axis. Your y-coordinate tells you where you are on your y-axis. Dichotomistic pairs just compare the logical implications of 2 words. And so we've shown like the opposite of less is more, not greater. The opposite of range is basis. It is what it is the basis of mathematics. And ing is the fundamental dichotomistic pair for sound. Sounds are represented by syllables. And so, we introduced in my language series the likeness bias. What am I like? What do I associate myself with? Well, linguistically, how would we bridge the concept of likeness bias to literally an argument about a single letter alone? I don't know. What's that thing? What's that thingy? I'm not too much of a math guy. I'm kind of mathy sometimes. You know, I like to go to formal events, but if they're not too formal, they're formal E. Every time you put the letter Y at the end of a word, it becomes a dimensionless quantity or dimensionless a word, but dimensionless, it represents a dimensionless quantity. The letter Y bridges the likeness bias to geometric linguistics directly. That is an empirical fact. That is what you're doing when you say the sound E at the end of a word. You're saying, I'm like something. Facts. So, again, I just have basis and range. The natural opposite for range is basis. I did want to talk about range as a physical demonstration. I'm not actually going to do the demonstration, you should just think about it. But how many people have ever been to a concert? How many people have ever been to a concert where you can't hear yourself? It's your favorite band and you're screaming, but you can't hear yourself actually singing. Right? Range is bounded by tension. And when you're at that concert trying to sing and you can't, it's because the resonance of the artist is coming through the speakers and it's physically more resonant than what you can produce. That's why you can't hear yourself at a concert. Conversely, like if you're learning to sing, if you just take you can literally take the end product, right? The way I like to learn to sing is literally take people singing, and the science of music production is limiting the ambient noise from your environment, from your recording room, from your auditorium, whatever. Like when you're listening to a mastered song, like a completely radio quality song, the resonance in the voice, in the song, when you're hearing it on the radio, is the exact same resonance that's being produced by the person. The difference is they're taking away, right, if you can't sing loud, they're taking away right, that's why you go into soundproof rooms, is so it limits the inefficiency of the sound within the room. So those are just some physical examples of vibration and resonance, or of singing. But there's a couple other actual physical demonstrations, again, I'm not going to do, but you should look up for vibration and resonance. Just go look up people. They'll just have like a metal plate, and it'll be vibrating it at a given frequency, and they'll have a bunch of granules of sand just on the plate, and when it vibrates at different frequencies, the particulate will coagulate into different geometric patterns. Direct empirical proof of vibration producing resonant patterns. Additionally, I have my metronome right here. Widely popular demonstration. If you take 5 metronomes and you put them on a free moving plank on 2 cylinders, and you put them at different tempos, they will synchronize. That's a direct proof, empirical proof of rhythm and synchronization. And now remember, we're talking about bridging ontologies. And so the proof is simply showing, yep, these words are more appropriate for this physical experiment. And it is. It's already the verbiage we use. We say the metronomes synchronize. Synchronize is not a word in a domain of quantum field theory or of general relativity or of a known mathematical ontology. So those are just some pointed proofs and examples and demonstrations I wanted to point out that I'm not going to do. And then let me make sure my camera's still on. So to finish up this episode or discussion, I just wanted to point out, I wanted to show you, again, the big thing I wanted to demonstrate in this episode was the E, that the letter Y at the end of a word represents a dimensionless quantity, and the letter Y is representing the sound E. And an example of that, the fundamental example of that, is A, the not specific direct article in the English language. An, equivalent to A. Any. Any is an with a Y at the end. Now think about how many times you've said those 2 words. You probably have never made that logical connection. An, any. Literally the same word with a Y on the end. Anything. A, an, any, many. Many is the word man with a Y at the end. One too many. The pariah tribe that we introduced at the very beginning of these lecture series. This is the proof of another valid empirical fact of why it's a natural base 2 number system. 1, 2. 2 are the only. There was no one around at a time when radiation was the only thing that existed. But 1 too many. Man E, like man. How many people are there? Many. And range is unlimited, basis is limited. And that's what I was talking about with the example at the concert. And now conversely, if you were a musician yourself, when are you done learning an instrument? Never. I mean, you can always improve. Sorry, my camera cut off right as I was finishing up, but the last thing I just wanted to say after when are you done, if you're a musician, when are you done learning an instrument? And the answer is never. That is the direct proof of basis, being able to play an instrument, and then range, how many musical pieces can you write once you learn an instrument. And then to see the example of the any, and any, many, 1 too many, There's a popular song by Luke Combs and another country artist, I just forget who, but it's literally one too many. Haven't listened to the song in several months or a year, so I kind of forget whatever the melody was. But this is clearly logic as in counting, 1, 2, a lot. And then there's another song by Keith Urban called One Too Many. And that's just, you see two spelled T-O-O. So you just see popular country artists and writers literally playing around and writing songs with all of these logical ideas we just introduced instinctually. Because again, realization is available to anyone who wants to try. And when you're trying to make money, you're trying to connect to other people. And when you write a song, you're trying to use the basis of agreement. You're trying to connect and relate to another person. So there you have it. That is the actual first lesson in dimensionless analysis. A brand new mathematical subject. And I still have not been paid a single penny yet. Wow. Humanity has failed. Thanks for watching, and check back for more.